Hello, my name is Bailey. This question is for Chris. What was high school like for you?
Well, it was the 1980s, so the music was different, the hairstyle was different, the clothes we wore were different than today, but probably in 5 or 10 years it'll be the same. And in school, I was just like you, probably all of you there. I tried my best. I didn't always succeed, didn't always do well, but I put my best effort into school. Math and science were kind of my favorite subject. I didn't really like English in reading too much, but I've since grown out of that and I enjoy reading now. And I played a lot of sports. And all of that happened in a little town called York, Maine, across the United States from where we're talking to you right now.
Across the United States from where we're talking to you right now.
The atmosphere looks incredibly flat.
Astronauts are really, really good at making pictures in space that look like you've never left the planet.
Stuff in space.
When you're there and you're looking out of a window and your thoughts stray sort of elsewhere, so slightly more philosophical things about who we are and our place in the world and all that stuff.
Yeah, absolutely. When you look out at the Earth, especially when you're in space for long periods of time, there's a couple of things that I think about. One is the atmosphere looks incredibly fragile, almost like a contact lens over an eyeball.
Millimeters above the surface of this globe. That's his edge of space jump. Now, you know, I don't. It's fine. He wants to. I don't have a problem if he does it, but the honesty of it would greatly diminish what I think people thought he was actually doing. And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. So in the photo, you see this curvature of Earth's surface, and he's, wow, he's in space. Look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat. That stuff is flat. That stuff is flat. The Earth isn't flat. And by the way, this is called gravity.
What is gravity?
I have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. Okay. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know. I don't know.
Has nobody been to the moon in such a long time?
That's not an 8-year-old's question. That's my question. I want to know, but I think I know. Because we didn't go there, and that's the way it happened.
Now, one thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth. There's no place to go.
Go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
So many times during spacewalks outside the International Space Station, we can see air bubbles rising up. Can you touch on how there are air bubbles in space?
Can you be more specific? Air bubbles?
So yeah, like a lot of times during the footage, the NASA footage, you can see bubbles coming up out of the helmets or kind of from underneath you. How do you explain bubbles in space?
Yeah, I'm not sure exactly what you're talking about. Now sometimes you get water in the helmet, and it's either from sweat or from the cooling garments. And in some of my spacewalks, I had like water in the helmet, not like I was going to drown in the helmet, but just little bits of water probably came from sweat. Often on the outside of the space station, you'll liberate little pieces of it's a really harsh environment out there, and the outside of the space station gets beat up pretty good. And sometimes, you'll see just little flecks of paint or something that you might have disrupted floating away from the suit. And, that's generally what that is. I've never seen any kind of air bubble anywhere.
Yeah. Could it be that you're filming in an underwater pool and you're not really out there? All right, well, I just encourage everyone to look up Bubbles in Space, #Bubbles in Space. Thank you very much. Thank you.
When you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar corona what stars we could see. I don't remember seeing any.
In 2002, Blue Marble 2.0, NASA's Rob Simon made this. And it had wide appeal too. For example, it ended up as the default background on the iPhone.
I didn't even know until I bought an iPhone and turned it on and kind of did a little happy dance.
Simon's job is...
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the Moderate Resolution Imaging Spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it was a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be.
I'm gonna step off the left now. It's one small step for man, one giant leap for... So, I guess you want to do it again. Okay. Sorry, Mr. Gorski.
As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
The next question from Marcia Dunn at Associated Press.
Marcia Dunn, AP. What was going through your mind? How amazed were you to see your roadster up there with Starman just cruising along with the Blue Planet? And how long will we be getting live views, do you think, from the car?
Well, I think it looks so ridiculous and impossible. And you can tell it's real because it looks so fake, honestly.